It's the best we can do for now. I'm not gonna.
And the cable also comes with CPA cable.
Alright.
The cable. Yes.
Yeah, I guess if you want to unplug the USB. Yeah, that works.
Yes.
Okay. Alright, so let's, we're going to start with a simple problem, which is like, calculate your expected grade, okay? And so, A will be worth 4, B 3, C 2, and the D is a 1, okay? And so we'll assume these are our probabilities. So we can calculate, alright, what's your expected grade based on these probabilities? And so it's just equal to the sum of x in the set of x times p of x. So we always start just by writing our basic equation. Okay. And so here we know we're doing x equals 1 to 4 of x times p of x. Okay, so at this point we can just start plugging stuff in. So it's going to be 1 times 0.1 plus 2 times 0.2 plus 3 times 0.4 and 4 times 0.3. Any of you have a calculator?
Yeah.
It should be around a 3.
3 point something.
Yeah.
1.2.
What is it?
2.9.
No.
1.2 plus 1.2 times 14 plus 3 times 4 plus 4 times 2.9.
Really? Oh, okay. 2.9. Maybe that makes sense. 2.9, sure. Exact? Or is there... Okay. Alright, so... Actually, that makes sense. That's right. Average grade tends to be a B minus in the class. So 2.9 is B minus. Or just a little bit above B minus or below B. Okay. So let's say we now ask the question, well, this is your expected grade. What's your expected grade given you attend every lecture, you attend class? Okay? And so I can tell you from history, or typically, nobody has ever failed that has attended every lecture. Okay? I think the distribution becomes something like 0.4, 0.5. Actually, that's probably wrong. This is probably still 0.3. And that's probably still 0.2. Is that right? Is that out of the one? What moved? Oh, so that
1G to B.
Let's change this. There, how about that? So, does that add up to 1?
Mm-hmm.
Yeah, so a little, you're more likely to get an A, more likely to get B, more likely to get a C. So we sort of split that up. Does that add up right?
Yeah, the one divided by A and B.
All right, so now the question is, what's the probability, what's the expected grade you're going to get given that you go to class? Okay? And so this is the probability of your grade given that you go to class. So really, we're just applying the same thing at this stage. Okay, so we still apply the expected sum of x times the probability of x, but this probability is given that you went to class. So it's still the sum of x equals 1 to 4 times x times p of x, but now it's conditioned on going to class. Okay, now in this case, I gave you these probabilities in this table here. So the calculation's the same. It's nothing new. Okay? So it will be 1 times 0 plus, what is it? 2 times 0.15 plus 3 times 0.5 plus 4 times 0.35. And we have a 3.2. 3.2. Okay. So the expected grade is going to go up. All right. So what if I don't give you this distribution in an easy way where you can just plug it in. So I think that's where the problem came up in this. Okay. So can I erase all this stuff? Yeah. I'm going to erase this. Oh. Yeah. Okay, so again, I'm just making up numbers, so these numbers might not be consistent with reality. Okay. So in this case, we're going to have a joint probability table. Okay. And so I'll try to fill in these approximately how I think it is. I don't know. Let's see. This is going to be hard. 0. I'm just going to make up numbers if that's okay. What is this all out of? Oh, that's too much. Way too much. What is that? 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. Yeah. Okay. So this is our This is a joint distribution because it tells us the probability of all combinations. Okay. So, for example, if we want to know what's the probability you get an A in the class and you went to class. Okay. That's equal to 0.3. All right. What's the probability that you didn't go to class and you get a B? 0.1. Okay. This really isn't that helpful. I mean, it kind of is, but it isn't. Usually we ask questions like, what's the probability you get a B given you go to class or not? This is, for most students, like, this is actually a more reasonable question to ask. Because you're deciding, like, should I go to class or not? Does it affect my grade? Right? So this is usually what we ask. So joint distributions are actually a little bit hard to understand, at least in my opinion. Okay? Or, you know, they're varying usefulness. Okay. So what we're going to do is we're going to go back and calculate what's our expected grade given that we go to class. Okay? And actually, we need one more piece of information. We need to know what the probability that somebody goes to class is. Let's say, I don't know, 60% of people go to class. All right. So we're going to calculate our expected grade given we go to class. So again, we just write our equation down. And I'm using somewhat abusive notation, right? But hopefully we understand what's going on. But I think this follows more or less. Okay. So what we need to do is actually count. The problem is, in this case, I never gave you this quantity. Okay? So we can certainly write out the summation. All right? So this summation is going to be 1 times the probability. Again, this is 4, 3, 2, 1. Okay? So probability of 1 given class plus 2 times the probability of 2 given class plus 3 times the probability of 3 given class plus 4 times the probability of 4 given class. Okay? So we need to calculate each of these quantities, these conditional probabilities. I'm going to erase this stuff up here and we'll calculate it out. So the first one, we'll just calculate what's the probability of getting a D given you go to class. Okay. So from the law of conditional probability, we know that's equal to the probability of getting a D and going to class given that you went to class. Okay. So we have all these values. The probability of getting a D, which corresponds to 1, and going to class is 0. Okay. And the probability of going to class is 0.6. So that's just 0. Okay. Next, we'll do the probability of getting a C and going to class. We do the same thing. That's the probability of getting a C and going to class over the probability of class. Okay, so what was this?
0.1 over 0.6.
0.1 over 0.6.
Times 2. And then
Wait, why times 2?
when you have to.
Oh, yeah. So, right, yeah. But we'll plug that in later.
It's 0.33.
0.3.
Continue.
So, 1/3. No.
Yeah. No.
No. It's just 1/6.
1/3 is 0.33.
Yeah, but this is 1/6, right? But
Yes.
yeah, because you multiply by 10. Got it. Yeah, I know where you had it.
You go fractions now.
You're ahead of us. Okay. So now we're going to do the same thing for getting a B.
One third.
Yeah, that's 1/3.
So 0.2 over 0.6, 1/3. And finally, probability of getting an A given you go to class. Two-thirds?
1/2.
1/2.
This is actual stats?
Yeah.
Oh, Lord.
These might not be right, but those are right. That's actually true. That's really dang close to true. Okay, so now we can start plugging stuff in, right? So again, this guy was 0, right? This is 1/6. This is 1/3. And this is 1/2. Okay, so now let's start plugging everything in. So we have 1 times 0 plus 2 times 1/6 plus 3 times 1/3 plus 4 times 1/2. Okay, so 0, 1/3, 1, and 2. So
3.33.
3.3.
3 1/3.
So this is your expected grade given that you went to class. So again, you'd go through this more complicated version if you got a table that looked like this that
If
gave
not-
you the joint
If
probabilities.
not, we get a table.
Say again?
If you not have a table,
Yeah, then you can't do it
we
this
can
way.
do that.
Okay, so that's just, this is called a joint distribution. When you give the probability of like 2 separate events all in one table, right? So there's the probability of going to class and not class, and there's the probability of the different grades. And so when you put that all together, that's called a joint distribution.
It's much easier than 1 to 4.
Yeah, now I understand.
Yeah, I think that's easier than the football.